Hi everybody, it's Professor Stevens. I'm going to work this problem for you and I'm going to show you how to solve it 3 different ways. And we're going to start by using the quadratic formula. Then we will also do it by factoring. And then we will also do it by completing the square and the square root method. Alright, now the reason that I'm starting with the quadratic formula is because it is a pretty straightforward plug and chug, and we can get the final answers. We can also use Excel to help us with that and checking our answers, and it'll give me an opportunity to show you how to set up a quadratic equation calculator or solver. Alright, so what we're going to do here, first thing, before I even start doing anything right in this spreadsheet, I'm going to remind you what the quadratic formula is. Sure, a lot of us know it. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And I do always require students to memorize this because it's something that you will use a lot in mathematics, so you should know it by heart. That is the formula, and it works when you have this format of a quadratic polynomial or a quadratic equation. Okay, so when that is true, you can use this formula. So as long as you have a quadratic equation set equal to 0, then you can use this formula to find up to two values of x that will work to make this statement true. So let's go to Excel and start to set up a calculator. So we're going to have a place for A, B, and C. I'm just going to center everything in here. Make that bold and shaded. You don't have to do all this formatting, but I just want you to see how to set up a quadratic calculator. Then we're going to calculate the discriminant. And the square root of the discriminant. Then we're going to calculate x sub 1, which will be the first answer in our solution set, and x sub 2. And this will work as long as we have two real solutions, or we might have a repeated real solution. If it's a solution that has imaginary or complex number, then it will not, you'll see an error message here. Okay, so we had started with this equation 5x squared minus 36x equals 32. Actually, I can just write it here on this slide. So I'll write it out again. Solve 5x squared minus 36c equals 32. And we're going to solve it using the quadratic, I'm just going to abbreviate, formula. Okay, so that is actually what we are asked to do, that specific way. So I'm just going to set this equal to 0 first. So I'm subtracting 32 from each side. And then I can say that A is 5, B is negative 36, and C is negative 32. Then I'm going to have x equals negative, so looking at the formula again, I'm going to have negative B, which is negative 36 plus or minus the square root of negative 36 quantity squared minus 4 times A, which is 5, times C, which is negative 32. And all of this over 2 times A, which is 5. All right, and then we'll simplify all this, and then we will also check it in Excel. So I'm going to put in what I had there was 5 for A, negative 36 for B, and negative 32 for C. Now the discriminant is the part underneath the square root sign. So I'm going to first calculate this part under the square root sign right here. That's called the discriminant. Trying to spell that better. Discriminant. There we go. And the discriminant will tell us if we have 2 real solutions, or 1 repeated real solution, or 2 complex imaginary solutions. And the way we know is if the discriminant is positive perfect square, it'll be 2 real rational. If it's a positive non-perfect square, it'll be 2 real answers still, but they will be irrational, meaning that the square root won't go away. And if we have 0 for the discriminant, this plus minus part, which usually gives us 2 answers, will disappear, since we'll have just the square root of 0, which is 0, and anything plus 0 is just itself, so it really reduces everything down to 1 answer, which is considered a double solution. Or it could be negative under the square root sign, which means you would have I involved, because the square root of negative 1 is I, imaginary unit. And so I know I just said all of that, maybe you caught it or didn't catch it, but this, I didn't want to take time to explicitly write everything out, just because I think that could be covered better in a separate video, but I wanted to run through it really quickly just to remind us of those qualities of the discriminant. It helps us know what to expect in our solution set. So to carry out the calculation of the discriminant, we're going to go over into Excel and calculate. I'm just going to write it over here. What we're doing is b to the power of 2 minus 4 times a times c. That's what's underneath the square root sign. So I'm going to calculate that right here. I'm going to do equals, and instead of writing negative 36 by typing it in, I'm actually going to click on this cell because it's containing it. Then I'm going to raise it to the power of 2. Then I'm going to subtract 4 times a times c. Okay, and I'll just do that with regular numbers right here so you can tell what I did actually is true. First of all, negative b, or not negative b, but just b squared. So b is negative 36, quantity squared, minus 4 times 5 times negative 32. See, it gives me the same thing using regular numbers. And actually, I think I'll just write that here. B squared minus 4ac. So we have a visual on that. All right, then seeing that this, I don't know if that's a perfect square, let's see. So we're going to do this to the power of 1/2, which is the same thing as doing a square root. All right, so the square root of 1936 is 44. So notice that it reduces perfectly. It's not a decimal that isn't nice and pretty like this. This is a nice integer result, which means that 1936 is a perfect square. In other words, 44 times 44 is 1936. It's nice and clean. Whereas something like if I had 2 and I try to take the square root, this is not a perfect square. So that is an irrational number. It's irrational because you cannot write it as a fraction. And another way to know that is that it does not, the decimal does not terminate and it does not repeat. All right, so we have a perfect square. So I'm expecting to get 2 rational solutions. So let's see what we get here. So the first one, let's just look back at the formula real quick. It says we're going to take, I'll even plug this in so we can see it simplified. X, I want black this time. X, why can't I get black? Hold on, guys. Sorry, let me fix this if I can. Nope, it just does not want to. I don't know why. Okay, looks like it's doing it now. X equals, we'll simplify this to be positive 36. Negative times a negative is a positive. Then we have the plus minus. Then we have, under this discriminant, well actually I already simplified everything and got it to be 44 because we took the square root of the discriminant already, over 10. So now I know X is going to be 36 plus 44 over 10, or X is going to be 36 minus 44 over 10, which will be, what is that, 80 over 10? Or X will be, that comes out to be, let's see, 44 minus 36, 8. Negative 8 over 10, which equals, since 2 goes evenly into both of these, that would be negative 4 over 5. Okay, so that gives me a solution set, oops, two real and rational zeros, or solutions, or roots. Okay, different terminology for the same thing. That will be negative 4 over 5 and 8. Okay, those are real and rational. They can both be written as fractions, and there's no I part of it, no imaginary value. So let's go back over to Excel and finish carrying this out. So we know that X was going to be, in the numerator, we would have negative b, plus or minus, we'll start with minus first, minus the square root of the discriminant, and then all of that was divided by 2 times a. 2 times a. Right? And notice that I got negative 0.8, and notice that negative 4 divided by 5 is negative 0.8. So this actually is negative 4 over 5, which is what we got as one of our solutions already. Okay, so this is equivalent to negative 0.8. Okay. Right, back to this. The second solution is equal to numerator negative b. Last time we did minus, so this time we'll do plus. the square root of the discriminant divided by 2 times a. All right, and there you have the other solution that we already got. So we've just checked out our answers. We've gone ahead and programmed what we could call a quadratic equation solver. Actually will give you the answers as long as they are real. Cool, right? I know, it is. Okay, so we have completed, let's go back to the overview. We have completed solving the quadratic, solving using the quadratic formula. So now that we know what our solution set is, we've even used Excel to confirm those answers, and now we're going to try the other 2 methods. So let's start with factoring and the zero product property. Sometimes it's also called the zero factor property. They mean the same thing. Either you have a product, which means you're multiplying things to get 0, and either one of the things you multiplied to get that 0 would have to be 0, or even both of them. Meaning that if you have something like a times b equals 0, then it follows that a could be 0. Whoops, I meant to write a equals 0, not a equals b. It means that it's kind of like this. It's like an if then. If something multiplied equals 0, then one of the factors must equal 0. Okay, that's the zero product property that we're going to be using here. So what I was trying to say, I guess the shorter version of that, or maybe it's longer, could be either. We're going to solve 5x squared minus 36 equals 32 using the zero product, also known as zero factor property. So what we'll do is we'll start by setting it equal to 0. This is supposed to be an x here. X, subtract 32 from each side to set it equal to 0. And then factor. We're going to factor using the AC method and factoring by grouping. Okay, so A times C. Well, A is 5, C is negative 32, and when you multiply those, you get A times C product is negative 160. And we're going to look for pairs of factors that when you add them, the sum of them would be the middle term, negative 36. So you can start with the most obvious. Sometimes the closer the numbers are, the better, but since this difference is rather large, you might want to start with a smaller, with numbers that have a larger difference between them. But I'm just going to go with the first thing I think of to kind of show you very organically how you might start to come up with some ideas here. You could do, see, 16 times 10, and one of these, since the product is negative, one is going to have to be positive and one is going to have to be negative. They'll have to be different signs. And since the sum is negative, it means the larger number is going to have to be the negative. So if I do 16 times 10, I know that would be the larger number should be negative and the 10 should be positive. And that would give me a difference of negative 6, which is not going to work. And that is not meant to be an x, it's meant to mean no bueno, not good, did not work out. Okay, so we're gonna have to come up with another set. How about negative, or how about just 8 times 20? 8 times 20. Again, I would have to give the larger number the negative, so negative 20 times 8, which would give me a difference of negative 12. Okay, that's no good. How about, what about 4? 4 times 40. So we'll give the larger number the negative, and then you actually end up with a sum of negative 36, which is what we want. Okay, so let's make these red. No, no. Yes. Okay, so then once you find your factor pair that works, you're going to expand the middle term, this one here, and then you'll do factoring by grouping. So this, the first two, or rather I meant to say the outer two terms can be rewritten just as they are, no change. So I'm just bringing down those two outer terms and the other side of the equation. And then in the center, I am going to rewrite negative 36x using this factor pair as a sum. So I'm going to do negative 40x plus 4x. So notice that if you combine those like terms, you would get back to negative 36x. And then I'm going to group these pairs and factor by grouping. So I'm going to take out the greatest common factor from each of these pairs. So from my first pairing, the greatest common factor is 5x, which leaves x minus 8 inside parentheses. From my second factor pair, positive 4 is the greatest common factor, and that leaves me x minus 8 inside the parentheses. And this is a good sign, because if these two quantities match, you know it's working out. If they don't match, you could have made an error, or it's possible that factoring by grouping will not work with what you're doing. All right, so now we're going to do another step where we factor out the GCF, but now we're looking at this as one term right here, and this as a second term right here, and what's common to both of those? The factor x minus 8 is common to both of those. And then what would be left after factoring that out would be 5x plus 4, everything equal to 0. Then we set each one of those equal to 0, and I'm just going to switch back to black now. So x minus 8 equals 0, or 5x plus 4 equals 0. These are two ways to get a solution that works. So adding 8 to both sides, we get x equals 8 here, which was one of our solutions from before, so that's good. Then subtracting 4 from each side, I get 5x equals negative 4. Then dividing by 5 on each side, I get negative 4 over 5, which also was the other solution that we got previously using the quadratic formula. All right, so now we have completed the second step here using factoring in the zero product property, and we will go on to step 3, completing the square and the square root method. All right, so we are going to solve, oops, black. Solve 5x squared minus 36x equals 32 by the square root method. Now, notice that I didn't write completing the square and the square root method, because I'm just leaving it implied that if you're going to do the square root method, you have to have a perfect square. But I guess I shouldn't just leave that up to the reader. Let's write it. Must complete the square first. Okay, so some equations are set up so that you already have a perfect square binomial, and some of them aren't. So for this one, we're going to have to do the work of making our polynomial into a perfect square trinomial that can be rewritten as a binomial quantity squared. So we're trying to, whoops, I wanted the 32 first. Okay, so what we're trying to do is come up with something that looks like x minus a perfect some number squared equals another number, and then we can take the square root of both sides, plus minus, and there you go. So that is the goal that is in my mind. So I need to make this into a perfect square trinomial, which can be rewritten as a binomial squared. So this is, I'm just going to do a little reminder. So recall that the perfect square trinomial pattern is that if you have a minus b quantity squared, it will come out to be a squared minus 2ab plus b squared, and you can verify that by foiling this, and you will end up with that. And also, if it's a sum, let's say it was a sum instead of a subtraction there, then the only thing that would change is that this would be a plus. So because of this perfect square trinomial pattern, we know that if we can somehow complete the square by adding something on, that would make it possible to rewrite the entire trinomial as a quantity squared, then we can take the square root of both sides. So that's just one skill set for solving an equation like this. So let's go ahead and try to do that. Now, because of the perfect square trinomial pattern, there is always, well, actually I'm getting ahead of myself a little bit. The first step is going to be to move the constant term to the right, which was already done. When the problem was given to us, the constant was already on the right, so we don't have to actually do that step. It's already done. The next step would be to divide through by the lead coefficient, because we want our x squared term to have a coefficient of 1 before we get into the actual completing of the square step. Coefficient. And then we can start to add on something that needs to be added on, which is then add the square, meaning raise it to the power of 2, the square of half of the middle coefficient. Or the coefficient of the x term. Not the x squared term, but the x term. Okay. So I'm going to do, step 1 was already done. Step 2, we're going to divide through. So everything gets divided by 5, right? So I'll have 5, when you divide 5x squared by 5, you get 5x squared minus 36 over 5x plus whatever we're going to add squared equals 32 over 5, because that got divided by 5 as well, plus whatever we're going to add to complete the square. Okay, so we've done step 2. Now we're doing step 3. We're going to add half add the square of half that middle term. So we can rewrite the first term, we can rewrite the second term, and then inside our quantity here, let me just write everything out again. We're going to have 36 over 5 and divided in half. So that quantity squared, and we're going to do a little reducing here. 2 goes into 36. Sorry, I've got a weird Facebook thing popping up. 2 goes into 36 18 times. So I'm just going to write, let's figure out what's 18 over 5 squared. Do that really quick. I'll just do it over here. Equals 18 times 18. That'll be 324. So I'll write that as, I need a bigger box, plus 324, and then 5 squared we know is 25. So that's what's getting added on over here. So that is equivalent to what we've added here. All right, now step 3 continued. I'm just going to kind of bring it over here. And so the next step is I'm going to write that perfect square trinomial as a binomial squared. So that'll be x minus 18 over 5. Which technically there could be a minus in here already because it was negative 36 over 5 divided by 2, which would end up giving me a negative. Either way, works out fine. And then we have equals. Now we just have to simplify this part of it. So I have 32 over 5 plus 324 over 25. And I'm going to need a common denominator here. So I'm going to multiply by 1 in the form of 5 over 5 to get that common denominator. So then I'll have 32 times 5, which is 30 times 50 is 150. Let me say that again. I didn't say that quite right. I meant to say 5 times 30 is 150. 5 times 2 is 10, so 150 plus 10 is 160. And then the 324 all over that common denominator. And you can simplify that a little further to be 484 over 25. And I know 25 is a perfect square, and I'm willing to bet 484 is also. So let's check it out. So I'm going to do equals 484 to the power of 1/2, which is 22. So finally, I'm going to write this as x, if I can write, x minus 18 over 5 quantity squared equals 22 over 5 quantity squared. And I don't even have to write that. I can write it what you're probably more accustomed to. Let me show you. Is to have it be just like this, and then you take the square root of both sides, making sure to do plus minus on this side, the side opposite x, and you have to make sure to do that. It has to do with the fact that, let me use an easy example with just regular numbers. if I say I have x squared equals 4, then what can I get? What can x be that will give me positive 4? I could have 2 times 2, that would give me positive 4, or I could have negative 2 times negative 2, which would give me positive 4. Therefore, x, when you take the square root of both sides, if you were to not put plus or minus, you would only get one of the two possible solutions. You would only get this. But if you put plus minus, then you'll end up with x equals plus or minus 2. That's two ways that you can square something and get positive 4. Okay, so that's just on as a side note to help you remember why it is that we have to put that plus minus there. So then we have x minus 18 over 5. The square root got canceled, or the square, the power of 2 got canceled right here with the square root. And this is 22 plus or minus 22 over 5. Then x will just be moving 18 over 5, negative 18 over 5, move it to the other side by adding it. So we have 18 over 5 plus or minus 22 over 5, so that we get 18 plus or minus 22 over 5, which is what we had in the previous method, something like this, 18 minus 22 over 5, or x equals 18 plus 22 over 5, so that we get negative 4 over 5, or 40 over 5, which is 8. So again, same solution set as the other methods gave us. So that's how you solve any quadratic equation using each of these three methods. So let's see, how long did that take? So with me explaining it, it took me almost 40 minutes, close to 40 minutes. So that's with me explaining all the steps out. And so I would think anybody could do all of these processes, probably take you about, I don't know, 20 minutes maybe without explaining it to someone else and having to, you know, really think through all the parts and explain the background for certain steps. So even though it seems, I guess, maybe tedious or overwhelming, the idea behind this exercise is to give you experience with all three methods, connect how they all are doing the same thing for us, just from different approaches. And then you might realize also which of these was probably the easiest way to solve this particular quadratic. I don't know, I think completing the square wasn't the easiest probably. Factoring, I don't know, some people are more comfortable with factoring, so some people might really like that. Probably the quadratic formula is the most straightforward, but it does require that you're very careful with your numbers because you can easily mess that up. And of course there's another way to check your answers besides just using a quadratic calculator or a quadratic equation solver in Excel. You can simply type, plug in the answers. So let me minimize this, and I'm going to use it to plug in our solution set to our original equation. So the original equation had the solution set -4/5, comma 8. And we can even just check that plugging in. So to our original 5x squared minus 36x equals 32. Let's plug in -4/5 and make sure we get a true statement. So we have 5x squared minus 36x equals 32. And that's what we're checking. We want to know, does it equal 32? Let's plug in -4/5. So then we'll have 5 times 16/25 minus, or plus rather, because we have a minus times a minus, or a negative times a negative. 36 times 4, well, that would be 4 times 30 would be 120. 4 times 6 would be 24. So 144 over 5. You can also put this over 1 if it helps you multiply straight across. And then we have 32. Getting closer here. 5 divides evenly into 25 5 times. So then I have a common denominator of 5. And I'm going to add my numerators, 16 plus 144. When I simplify that, I get, let's see, 0, carry the 1, is that 60 divided by 5? And I believe if you do 5 into 160, oops, you can have 5 go into 16 3 times with a remainder of 1, bring down the 0, 2. So yeah, that's 32 equals 32. Okay. Another way you can tell that 160 is divisible by 5 is 16 times 10, 2 times 5. 2 times 16 would be 32. Okay, so we've checked one answer by plugging in. Let's also check the other answer in our solution set, which was 8. So again, 5 times x squared minus 36 times x equals 32. Okay, we want to know if it does. When we plug in 8, so that'll be 5 times 64 minus 8 times 30 is 24, 240, 8 times 30. 8 times 60 is 48. So -288. Then 5 times 60 would be 300. 5 times 4 would be 20. So we have 320. I must have messed up something somewhere because this is not going to come out to be, oh yeah, maybe it is. I don't know what I was thinking, so I think it's going to be just perfect. And that should be equal to 32. Keep going. 320 minus 288 is 32. I did that kind of weird, but 320 minus 288 2 3, right? Also, another way that you can tell that is 288 to get to 290 would be plus 2. Then to get to 300 would be 10. I'll just do these in blue. Oops. And then to get to 320 would of course be plus 320. And so when you add all those together, the difference that you had to make up to get to 320, or rather if you started at 320 and we're going down to 288, you would have 2 plus 10 plus 20 is 32. All right, so I know you guys have calculators and everything, but number sense can be a big asset in life. Having a reliance on a calculator is not always going to be very helpful for you. So I like to show different ways of thinking about getting the answers even without a calculator. And so we did figure out that this is 32, and so we're good. All right, so that completes the whole process. What did we do? We solved this quadratic equation 3 different ways. We also programmed our own quadratic equation solver and checked our answers using that. We also, by solving it 3 different ways, confirmed that we got the same answer every time, same solution set every time. We covered a lot here. We covered how to factor a quadratic with a lead coefficient other than 1, makes it more challenging. We reviewed how to factor by grouping. We reviewed how to add fractions and reduce fractions. We reviewed the perfect square trinomial pattern, completing the square, doing the square root method to solve the need for the plus minus there. And I guess this has been a thorough lesson, so I hope it was helpful, and if you have any questions, please let me know, and I will see you in class. Take care.